I'm just checking the crowd here. It's something synthetic, artificial. Anyway, David, come on up. It's great to have you back. David Cohen, this round of applause.
I'll just stay down here. Can everybody hear me? The mic on? Great. So, David Cohen, I founded a company called Decentral Tachyon, and we're really looking at trying to integrate AI, blockchain, cybersecurity, and IoT together so that we can build the right kind of protocol to run things around cybersecure transactions for the machine economy. And I want to talk about, one of the things I want to talk about related to that is what I'm calling AI 3.0. You can name it whatever you want. My definition of AI 3.0 is the integration of this Internet of Things that we talk about, blockchain, cybersecurity, and AI. So I think everybody said they know what AI is, artificial intelligence, and we'll get into talking about each one of these individual things. A quick story about how I got here is that I've been building decentralized software systems for about 25 years, and I was building like multi-agent systems so you could do decentralized control of things like smart grids, and it's been kind of an uphill battle trying to build trust into systems where you're trying to control things autonomously, where you have to be able to trust things. And so I started looking at blockchain, not because of cryptocurrency and not because I wanted a Lambo like everybody else on the ICO market, but I was actually looking at it from I needed to build something on a cool foundation. And if you look at like multi-agent systems, they're about autonomous agents doing things, and it makes people afraid because it's like they're doing things without me being able to control them. So what blockchain brings is the trust layer, but from my perspective, so I went through the whole research objective, and I know a lot of this conference is about the tokens, it's about the regulatory aspects, it's about everything. I think I'm going to cover a lot of the things that kind of bridge those things, but I was looking at IBM Hyperledger, I was looking at Ethereum, I was looking at all these different options, and then I found this thing called IOTA, and I thought that might be the nirvana because it was supposed to be scalable and no transaction fees. I've been really kind of moving through the universe of looking at all the different blockchain technologies, and I've kind of come across, recently, 9 months ago, I came across Hashgraph, which I think is actually a more scalable solution for what I want to do. Certainly, Hyperledger, Sawtooth is also very interesting as well. But this whole AI 3.0, what it means to me is it's not just, blockchain doesn't solve the problem for me. It's a piece of the puzzle, and so you integrate them all together if you're going to get into what I call the machine economy, or whatever everybody else calls the machine economy. See if we can click here. Technical. See, AI doesn't work. So Internet of Things, the main thing here is that I think of the Internet of Things as more of a mixing together of what everybody thinks of internet-connected devices with cyber-physical systems, where you have mission-critical things that are running smart grids and running very, very things that we rely on, where you get into mission-critical, privacy-critical type situations, or even life-critical situations. And now we're integrating that all together. And the main thing is that this Industry 4.0 is about having autonomous machines running AI, and you've got billions of devices that are coming online, and they're integrating with existing systems, and the existing systems weren't designed really to be integrated with the internet, and that's where the problem starts, is that the Internet of Things has really become more of what we call Industry 4.0. It's about, if you think about like what's the easiest way to grasp this, I guess it would be autonomous vehicles. You've got a vehicle going down the road with nobody in it, and how does that work, and how is that going to work in the future and work intelligently? So the second piece that's really critical here is cybersecurity. The cybersecurity attacks are on the rise. There's more threats coming in. There's more things that are integrated. There's more things that are connected. There's major threats to all of our systems, and this is really the piece that doesn't get talked about a lot, but for us, we're thinking about it from the foundational layer. It's like, what do you do first? You think about cybersecurity. And my example there is, if you look at Houston, we have a problem. So if you look at some of the things that are in the news, and this doesn't kind of alarm you, I don't know what would, but when you say hackers are going into my Jeep when I'm driving at 70 miles an hour and they're hacking me, and that's now getting into situations of life situations. The one about simulating killing a simulated human is almost comical, but at the same time, this is a serious thing. If you read the headline, it says, some humans are already hackable, and yes, you can do some serious damage. So, like, there was a president, I can't remember which one, that actually had his pacemaker disconnected from wireless networks because he was afraid of being killed. The power grid got hacked the day that we launched this project. So we were thinking about this kind of stuff because the last project I built was a smart grid software platform. But this issue of, if you think about this, if autonomous vehicle is going down the road and it's picking up on LiDAR data or picking up on sensor data, and someone hacks into that, and the data that's going into that control system is wrong, that you could crash the car. So that's a severity of what this can mean without the cybersecurity part. Okay. So AI, artificial intelligence, it's been around for a really long time. Everybody sees it with Siri. At this stage of the game, there was everybody's heard of the concept of the singularity, where AI becomes exponentially smart, and it gets to the point where it's as smart as humans, and then it goes beyond. I would say that AI right now is still in its infancy, because you can do things like, they can teach it a game and some rules to beat this 3,000-year-old game called Go in Chinese. And that's really great because it can do better than humans. And actually, when it was learning, it got to the point where it did better without human intervention. So that's either scary or it's really, really great progress. But that doesn't mean we're at the singularity, because if you look at these systems, they don't work. Okay. So, so this is a computer that saw this picture, and the AI was supposed to be really smart, and it said a young boy is holding a baseball bat. So this is the problem with AI, is that if you don't, it's not even close to being context aware and be able to be on its own. And so therefore the problem is, if you unleash AI onto the system and it makes mistakes, and it's doing things like, this is harmless, right? If it's doing things where you're actually trusting it to do something where your safety is at risk, this is a real problem. And so I would say the singularity is not near. It's not even close. But it's impressive in that the rule-based systems that AI can learn are getting really, 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 really smart. And then blockchain. So we are coming back to blockchain, because I know everybody's here for blockchain and cryptocurrency, and we're going to integrate that into the story. Again, it's a piece of the puzzle, but in my search, I was going through this whole thing, and I was looking at a bunch of different things. How do I determine whether or not this is going to work for me? Because ultimately, if this is going to work in systems like mission-critical systems, where you're talking about smart grids, or talking about military bases, or talking about even in homes and hospitals and buildings and common things that we trust, you have to be able to sell this to the powers that be and be able to get past some of these issues. So the stability of proof of work with the Bitcoin blockchain, it's not going to scale for this type of application. You're not going to be able to use the amount of energy used for proof of work for Bitcoin to run these kind of transactions. So I think the world is moving a little bit away towards proof of stake, and it's moving away from proof of work, even though it's still kind of, everybody still thinks Bitcoin is the main one. The transaction speed and what happens now when the system is offline, when you don't have an internet connection, what do? A lot of these blockchain technologies, they're in a simulated world, there's somebody controlling it, they're telling you it works perfectly, but what happens in the real world? So the other one is the governance. So I talk about this as like, who's really in control? The people talk about governance, this is a decentralized organization, but you look at some of these initiatives and there's 2 or 3 people behind it. And those two or three people are actually controlling the discussion. And so that's not really a decentralized organization at all. And did they roll their own crypto? I mean, I don't know if you guys know the story, but I was with IOTA at the time. I actually resigned, but they were starting to do things like rolling their own hash functions, cryptographic hash functions, and MIT challenged them on it and told them to fix it, and they fixed it. But the problem is that you just don't do that kind of thing. So the governance is really important because you have to be able to know that it's going to be stable, it's going to be in place, and it's not going to go, and it's not going to fork, and you don't have any control over it. So the open source thing is, again, another thing is, is the code under review? Do you have something like an open source kill switch? Again, with IOTA, they've actually admitted that they have a kill switch in it, that if you take it and you fork it, it's gonna self-destruct. I don't know what it's gonna do. It's just, you can't sell that to anybody that I want to talk to. So it's not a true open source project. Tokens, everybody's interested in tokens. What happens to all these technologies when you're using their token on a system and all of a sudden the SEC comes in and says, that's not a utility token, that's a security? What's the risk of you implementing that technology and now you've got to actually go back and say, I can't use it? So there's all these issues around blockchain. Like I said, in my travels, I kind of came onto Hashgraph. And Hashgraph has got, it's a really elegant consensus algorithm that before it gets into a cryptocurrency, it's actually doing everything that blockchain is doing, but it's doing it more elegantly, faster. It does it in a way where you can prove that all the transactions get settled. It's been criticized because they started off with a patented version and they sold it to some credit unions. But then what happened is now they're gonna unleash it as a public ledger. There's still some patents behind the technology, but they're doing it for the reason they can control the releases so that it doesn't get copied 100 times and then it turns into forked versions and no one knows which version is real. So they're doing it for, I think, a solid reason. But Hashgraph, again, is an interesting look at a blockchain. There are, of course, many others. This isn't the only technology out there. There's Raiden, there's Hyperledger Sawtooth, there's Cardano, there's Plasma coming out of Ethereum, things that are coming onto the market. So it's kind of a moving target, but the reason why I got interested in this is that if I'm going to integrate this into my technology, I have to be able to know that it works. And so the permission private version of this actually has been proven to work, and there's people that are actually using it. So that was important. So the AI 3.0, again, what am I trying to say here with AI 3.0? It starts with, from my perspective, it starts with cybersecurity. I keep going back to this issue that you simply can't build something you can trust on a system where if the data itself going into the system is fake or it's been spoofed, everything you're doing, whether or not you're trying to store your smart keys for your cryptocurrency, whether or not you're trying to drive down the road, any kind of data identity issue in this kind of scenario is built upon the idea of cybersecurity. So you have to have that in place. That's the foundation. And then you get into the blockchain piece. The blockchain is really good at a truth serum. It creates this permanent record. It creates a distributed ledger. It has all kinds of value that you can now make sure that any transaction you produce is valid and secure. But what if you have a blockchain running on a bunch of insecure computer nodes? It doesn't solve that problem. It only solves the problem when you're doing a smart contract between two nodes. So what about the node itself? What if you compromise it? So that's why cybersecurity sits underneath the blockchain. And now you've got these different things about being adaptive, decentralized learning and action. The entire world, the way they build cybersecurity right now, is all based on, you look at the network and in real time you use machine learning. You try to figure out what happened and tell people the problem after it happened so you can mitigate it. Because the hackers are already using super adaptive artificial intelligence to basically do whatever they want to do. They go into the network now. It used to be 2 years ago that you'd have to click on something for some kind of a threat or some kind of a malware to get into your system. Now the malware is going into the network and it's replicating by itself. And so you can't ever look back and say, we're going to be able to scan things from the outside, look at it from the outside in and fix the problem. So we have to fight that stuff. The hackers are ahead of us and think about how to have the actual device devices themselves develop personalities and learn. And so, like, there's been many cases of cybersecurity threats where hacker got into a system. I think they blew up some gas turbine. They compromised it, and they blew it up. So what if the gas turbine was smart enough to know that it's something I don't normally do, and just shut itself off and text the owner and say, should I be doing this? No one's doing this right now. But that's the whole, kind of personality, adaptive nature of devices. Because as these devices get autonomous, you start asking them to do stupid things. Right now, they'll just do it, and that's not going to work in the future. So the governance is the top piece. Where I say teach your machines well. If you look at like things that run really well, like airplanes and smart grids, they're run by standards. So you can't do stupid things on a lot of electrical systems because they're actually standardized, and you can't ask it to do stupid things. So the rest of the world is going to move towards autonomous systems. That's to think about who's going to govern this, what standards are they going to meet, and that's what I call AI 3.0. That's where this is a long-term project. There's got to be, the entire world has to help us with this process because it's a lot of people working on it. We're working on this cybersecurity funnel. We're trying to make it so that as you go through this funnel, and this will all be open source, it'll be harder and harder and harder for someone to attack the end node. And since the time's kind of running light here, we have a whole strategy and a platform that we've launched under the company Decentral.ai. Some of it's patented, but what we're doing is we're taking that and we're pushing a lot of it into the open source world. And so this is going to be based on like an Apache 2.0 license. It's going to be a true open source foundation. We're launching it in Q3 of 2018, and we have 10 projects right now that are going into it. And what we want to do is build a lot of people helping us globally to build that out so that they can actually deploy solutions that utilize blockchain. And I'll just say one more thing about the blockchain is that our whole notion of blockchain is that we're not a blockchain. We're not trying to build a new blockchain or a new cryptocurrency. We're going to integrate and leverage the best of breed stuff that's out there so that people that want to integrate, they want to log onto the blockchain, they can use the ones that we support and the ones that we think are the most viable. So with that, I want to say that's something that you'll be able to see on our website, that when we launch it, we would actually like to get a lot of people to collaborate with us on this, because so far there's been somewhat of a war going on between the blockchain companies. You have IOTA, and you've got Ethereum, and now you've got Hashgraph, and you've got all these companies, and they're all saying they have the best solution. I think what the industry has to do is realize that maybe there's really good benefits of different technologies that are good for certain industries, but everybody needs to work together. So what we're trying to do is pull everybody together into an open source initiative that, of course, we will have, just to be transparent, we will have an enterprise version of this that we're going to want to sell to the customers that want that. But to get there, we want really to work with all the different blockchain technologies. The cybersecurity part and the AI part are just kind of like the wild, wild west. So we have to really, there has to be a lot of people working on this for anybody. Like if you look at the Department of Defense, for instance, they're now saying they won't take software unless some of it's open source, because you can't get enough eyeballs on it to understand what's happening in real time. And the hackers are moving so quick. So I just want to say we'd love to have everybody participate with us in the open source initiative at decentral.org. And that's it. Thanks.
All right, excellent. Thank you, David. Appreciate it. Michael Ullman will be up here in just a few moments and talking about one of my favorite topics around voting and voting reform, which I think is fascinating. I think it's one of the really strong use cases for the blockchain technology. Also, those of you that were interested in things like Hashgraph, obviously talked to Eric from this morning. He's got an interest, and of course talked to David. He's got an interest. How many people were aware of Hashgraph before today? Right. How many people just heard of Hashgraph today? Right. So it's kind of a little bit of a mix. I think what you're going to find for those of you that just heard of it is you'll get online and Google it and get on and check out what's going on. It's very cool. So definitely recommend you look at that as well. Okay, and like I mentioned, food. We have another